Hello there, I am Vignesh. I live in Chennai. I am basically a software engineer, developer. I enjoy working in Java. I have been in the industry for the past 8-9 years now. Today I have taken this opportunity to talk about my solution, the solution that I have created for fingerprint authentication recognition based on neural networks. The idea behind neural networks and the approach chosen will be discussed quickly. Now I'll take you through the chart that I have prepared here, right? So it is not visible from there, I know, so I'm going to take it closer and explain you one by one why have I chosen this approach and what are the pros and the cons, and we'll take it from there. Right, so this is a chart that I have in front of you, which I think you should be able to see. Right, so this talks about neural network based pattern recognition, and I have discussed one by one the various neural networks available. Well, neural network, if you think of it, it is basically a concept developed to simulate or emulate the behavior of a brain. Why do we have to do that? Well, reason being, there are things that the brain can do much easily, much simply, and and the things that the brain can do much simply, easily, are the ones that are not easy to program and perform through a computer. For example, let's say you want your computer to recognize a face in a group of faces. It's not possible because we don't have ready-made algorithms for that. There is no conventional way of doing it. So what we end up doing is we end up simulating the brain, and hence the concept neural network. Well, the neural network, there are so many kinds of them, and there are so many applications of neural networks. Primarily, and the most importantly for today's discussion is the use of it in pattern recognition, so that it can be used in fingerprint authentication or the patterns that are created from the eyes, retinal patterns. So they're also used in image analysis and enhancements. They're also used to do a lot of other things. But the topic of today's discussion is going to be pattern recognition using neural networks. So to give you a brief introduction about the various neural networks available, well, this has been a topic of R&D for quite some time, and it will be. The most popular one among the neural networks is the feed-forward neural network, right? A neural network is basically made of neurons, just like our brain cells are made of neurons. But here, in the artificial neural network, ANN shortly, is made of a weight being a number. So this one can be called a neuron, and this weight in the neuron is basically a number, and each neuron will have a activation function, a function that gives us the output, gives out the output based on the weight. And a neuron can have one or many weights. So that's pretty much the idea about a neuron. So this back propagation algorithm or the feed forward neural network is basically this diagram that I'm showing you to you now. It basically takes this input, and it may have several layers, layer 1, layer 2, and then there will be a function which gives the output. Now the output for this is usually a true or a false, or 1 or a 0. So the input here we have taken input as our fingerprint or any pattern for that matter, and the input is given to the weights. There can be interconnections between weights among different layers. So I've shown this interconnection, and each weight can be connected to all of the neurons. I mean, each neuron can be connected to all of the neurons in the subsequent layer, and so on and so forth. And so there can be many interconnections, and these weights decide the output of the neuron, which is a function basically, and it's stored within the neuron or outside anywhere. So that's the idea. And when you give this input and each neuron gives us the output, it is fed to this single function which calculates the output 1 or 0, right? And say you want this neuron to give a positive output for one fingerprint. Say we are dealing with fingerprints now, right? So and let's say this network is supposed to give a negative output for some other fingerprint. So we'll first feed the correct or the right fingerprint, and we'll try to get a positive response. I'm sure first time when you give it, you won't get the positive response, so there will be an error. That error is back propagated, and the weights are adjusted accordingly. That's why we talk about back propagation algorithm here. So for a given input or an image or a pattern, the weights of neurons are adjusted so that it gives a positive response. And when the bad samples are given, again the neurons are adjusted using the back propagation algorithm so that it gives a negative response. So the whole neural network is very much dependent on the samples that you're given, and the more the number of samples you give, the better the response of the neural network is going to be. And this is particularly not good for critical applications like fingerprint recognition and authentication, because there are just too many samples to give to this network, right? And you don't know, you might have missed some samples, and it's Herculean task to give all the possible wrong samples and all the possible right samples to this neural network, and train these weights. But this is very useful for other kinds of applications, like say the ones that are not so critical, and ones that are very simple. Like say you have to recognize a character or a letter in a given given image, right? Suppose you give a 1 or a 2, and you want it to recognize the given image or the pattern to be 1 or 2. This is apt for that, and there are so many other applications of this neural network. But for the purpose that we are looking at, this is not a good idea. So what we are left with is this self-organizing map, which is based on coherence self-organizing map, SOM. The SOM